Hello, Hawks. Welcome to the Volcanoes module. Today we're going to start off with a little introduction. What is a volcano? What do you think it is? I'm going to pause here and let you tell me. That's right. Basically, it's an opening in the surface of a planet or a moon where gases and magma and stuff seep out from it or explode up out of it. Scientists will classify volcanoes in about three different ways, more than that, but mainly three different ways. The first one is the size and the shape of the volcano. So there's three main types. There's way more than three, we'll see in just a moment, and they're shaped and sized differently. So for example, the first one on the top left is a fissure volcano. It's flat. There's just magma that's kind of running beneath it and just a crack in the opening. The shield volcano, think Hawaii, not great big giant mountains, gentle sloping. The rest of these are bigger and taller. The caldera volcano was a composite volcano that exploded and then collapsed in on itself. So now it's got a great big crater in it. Another way that volcanoes are classified is by the type of eruption. There's several ways: explosive or gentle flow of lava. So here's some differences here. The ones you see exploding are not so gentle. With the great big plumes of smoke, you can see those are going to be the more explosive, and the other ones on the right there are top right, are just gently flowing. And then the stages of the volcanoes. You've probably heard of these before: active, dormant, and extinct. Those are the three stages volcanoes can be in. What does that mean? An active volcano, the magma chamber underneath it is still gurgling and moving around and close to the surface. A dormant volcano, the magma is there, it's underneath, but it hasn't been doing anything for a while. So it's either filling or emptying. And then the extinct volcano, the magma chamber is completely empty. There's an example of an active volcano that is Kilauea in Hawaii. It doesn't always smile like that, but I guess this day it was extra happy. A dormant volcano, Yellowstone, is an example of that. And then here is a sad extinct volcano. Poor thing. Predicting eruptions. Do you think scientists can predict eruptions? When we learned about earthquakes, we said they can't predict earthquakes. But can we predict eruptions? Well, kind of, sort of. So scientists are going to look for some different signs. One is steam and ash coming up from the volcanoes. Now, some volcanoes regularly have a little bit of stuff coming out of the top of them. When there becomes more and more, then it's more likely to expect an eruption. Earthquakes around the volcano can cause little cracks in the ground. And when that starts to happen, scientists go, maybe it's a little more active than it was before. Believe it or not, the tops and sides of these mountains can start to bulge before they explode. So the gas and everything is building up and building up and building up. That's what happened right here. This is Mount St. Helens, shortly before it exploded. So on the left is before, and on the right is after. It blew its side and top right off. Gas and sulfur escaping. Now, this does not always mean it's about to erupt. There's more steam and gas and sulfur escaping than usual. There's places you can go visit where they're always steaming, and it's really super stinky. Sulfur smells like rotten eggs. All right, so like sulfur is smelling. It smells like rotten eggs and farts. And if you could smell it, if this was a scratch and sniff video, what would it smell like? And it's boiling. Ew, stinky boil. So there's ways that we describe volcanic eruptions, and most of us think about big explosions that are really destructive. And what we mean by that is there's ash, lateral blasts, pyroclastic flow, and mud flows or lahars. What are those? Ash. When ash goes up into the sky, it can make it look like it's foggy or lots of snow, and it totally blocks out the sun. It can kill plants and crops. contaminate water supplies. Poor fishies. And roofs and buildings can collapse. When we think of ash, we think of it being really light, but it's so fine that when it collects more and more of it and becomes wet, it's really heavy. There's another example of ash falling. Another way they can be destructive then is lateral blasts. That's Mount St. Helens. A lateral blast means that the volcano is exploding sideways, not just up in the air, but sideways. And it can just destroy everything in its path for miles. So that's after Mount St. Helens, all the trees that were around it just got obliterated. Pyroclastic flow. This is pretty interesting. It's very hot ash and lava fragments from the gas that's escaping. It's poisonous gas and it's moving really fast. We talked about hurricanes and how fast the wind blows in the hurricanes, right? And it's got to be above 74 miles per hour. The pyroclastic flow can be going a lot faster than that. There's another example of some pyroclastic flow. I have no idea if there's somebody in that little vehicle down there. I sure hope not. And another way to be destructive are the mud flows and lahars. So a lahar is like a mud flow, but it's got all kinds of debris in it, and it's got all the ash and everything from the volcano erupting. Right? So again, it's going to destroy everything in its path. It's very, very heavy and thick, like concrete, and because it's so fast, it can cover things up really quickly and really, really bad. You don't want to be caught in a lahar. Volcanoes can also be constructive. When a volcano is constructive, it means it's going to do all kinds of good things. Constructing means building, so it can build up different things like beautiful landscapes and rich soil, hot springs, geothermal energy, and new land. So when there's volcanoes, you're going to see beautiful landscapes like this one in Indonesia, Tokyo, Mount Fuji, Tanzania, that's Mount Kilimanjaro. And oh, look at that. That's in Washington. That is Mount St. Helens. It can enrich the soil, which is really weird to think that it gets covered up, but then the ash has nutrients for the soil in it. So when all of that clears and sinks into the ground, it's actually really good for the plants. Hot springs. A lot of people like to swim in hot springs. It's nice warm water coming up from the ground because of the magma that's so close to the surface. So a lot of people love to go to the hot springs. They're all over the world. Geothermal energy. This is also hot springs. This is in Iceland, though. Iceland gets its heat from the hot water because Iceland is very, very active with the magma underneath it. So that's pretty cool. And new land. This is Hawaii. The big island of Hawaii is a giant volcano that is constantly erupting, sometimes more violently than others. Sometimes it's just flowing gently, but it is always erupting. And every time that hot lava hits the ocean and cools, it's creating new land. All right, little test here. Magma or lava? I'm going to show you some pictures, and what I would like you to do is just shout out whether you think it's magma or lava when you see the picture. Ready? Magma or lava? 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 If you guessed magma for any of them, magma is below the ground. Lava is on the surface. So you can't see magma, you can only see lava. The only difference between the two of them is where they are. So anything that you can see is considered lava. What you can't see is magma. And we can't see it, so you just have to trust me on that. Let's talk about viscosity, big fancy word. Viscosity is basically just how thick or thin something is. So friction of moving fluid, if it's got a lot of friction, it's going to move slower. So for viscosity, we say something has low viscosity, so not a lot of friction if it's able to flow quickly. High viscosity means it doesn't flow very fast at all. And you can see the stuff that whatever is in those beakers, the ones on the right are very high viscosity. They're very viscous because they're hardly flowing at all. The viscosity of water and honey, which one has a high viscosity and which one has a low viscosity? So remember, it's friction. Which one has a lot of friction? Which one has just a little bit? Honey is high viscosity. There's more friction. It's thicker, stickier. Low viscosity, water. Low viscosity, when we talk about magma, means that the lava is flowing gently and smooth. It might like shoot up like in this picture, but it's very light little bits of lava. It's not thick and sticky. The gas that's in it will escape really quickly in little tiny bubbles. And the eruption, we consider it quiet and gentle. High viscosity, on the other hand, high viscosity, the lava is sticky. It flows very slowly. Sometimes it doesn't flow at all because the gas pressure is building up and building up. So the gas doesn't have little tiny bubbles that escape quickly. It's one, think of it as one giant gas bubble that's trying to get out. And we're gonna play with this. We're going to try to demonstrate this. That's more of a high viscosity type of eruption. Homework. Homework? Homework. Yes, you have homework. Don't freak out yet. Remember, all homework is optional. And this one is fun. You're going to want to do this. Be sure to substitute non-milk products if you have allergies or are lactose intolerant. Here we go. This is a two-parter. Part one. Step one, make some chocolate milk. Step two, use a straw and blow bubbles in the chocolate milk. I'm sure you've all done this. Am I right? You've done this before. Yeah. Step three, point to the milk and say low viscosity. So there's lots of little tiny bubbles and they're all going blah, 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 and coming to the surface and it's not exploding, right? It's low viscosity. Make sure there is somebody there to hear you say that. Maybe it's a parent or a sibling or a dog or somebody who point to it and say low viscosity and then drink it. Part two, make a milkshake. You don't have to make one necessarily. You can go buy one. But, choose a flavor. It doesn't matter. Make a milkshake. Step two, use a straw and blow bubbles into the milkshake. If you've never done this before, it's quite interesting. If you have done it before, you know what I'm talking about here. So are there lots of little bubbles? One big bubble? Point to the milkshake as you're trying to blow bubbles in it and say, high viscosity. Make sure somebody knows what you're talking about. You're pointing to it. You're saying high viscosity. And then drink your milkshake. That is your homework. If your parents don't believe you, have them watch this video. We'll check in with you next time to see how you did with your homework, and you can share with everybody how it went, share the flavor that you chose, and we will see you next time.
Low viscosity.
Do it again.
Low viscosity. High viscosity. Okay. Amazing.